economists for reducing the overall emissions. And it's the overall emission that also impact, that decide on the impacts in Europe. So given the fact that these mitigation discussions are difficult, we also thought in the Commission it's time to think about adaptation, that climate change might become 2 degrees, 3.5 degrees, if we don't do anything. And so we have to think about adaptation. So the study we made is in support of developing that policy in Europe. The question is whether adaptation is a European policy or should be a member state policy or a local policy. The mainstream thinking is that, well, adaptation is local, impacts are local, so it's up to the governments, it's up to the cities to act, but that's actually one of the things we challenge in our study and show that adaptation also has truly European dimensions. What is different with, for instance, IPCC in this study? If you look at the IPCC reports, we have the first one last year on the science, and this year we had the one on impact and adaptation, number 2, and the third report was on mitigation. Well, the first and the third report are very quantitative. You have a lot of numbers, scenarios, graphs, and things like that that can support our policy making in mitigation, basically. If you look at the second report of IPCC on climate change impacts, vulnerability, and adaptation, it all of a sudden become much more qualitative. It's all, well, there is an increase there is a reduction there. There's a lack of real hard data on this. And this is what our study tries to do, to really do seamless modeling, starting from climate change scenarios, as we get from the science, and we use a whole range of scenarios, starting from these, using impact models, so to see how this climate change, changes in temperature, changes in precipitation, how it affects certain sectors like agriculture, health, tourism, and you name it. You have them listed in the press release. That gives us the impacts of climate change in all of these sectors in Europe. These impacts are important enough to express in terms of people affected or amount of land affected. But we go a step further and we do also an economic evaluation of these impacts in each sector, which is done by Juan Carlos and his team. And that gives us an overall impact of climate change on the European economy and on the welfare of European citizens. So it's really numbers that we put on the table. As maybe Juan Carlos will explain, the numbers are still underestimates. And I would say don't look at the absolute values of the numbers are not that important, but it's rather the comparative analysis of numbers in one sector compared to another sector, or the numbers in Northern Europe compared to Southern Europe, that is important. So that's, don't look at the absolute numbers, they are underestimated still, but look at the comparison between the numbers if you look at the numbers. Well, some highlights, I think, what comes out, the sectors that are most impacted or suffering from climate change in Europe are the health sector, agriculture, and infrastructure in coastal areas because of sea level rise. And the real surprise was really the fact that the health sector was so much impacted. So we look at the impact of heat waves, heat stress on premature mortality. And we come to assessments of about, by the end of the century, 200,000 people every year that would be dying prematurely because of just heat waves. That was a surprise. And if you come to the cost, as Juan Carlos would say, even if you put costs on that, it's even a bigger surprise. But I want to mention here is that if you look at these numbers, 200,000 premature deaths because of heat stress, that's about of the same order of air pollution that we did the same calculation for just air pollution. And it's also 200,000, 300,000 extra deaths. Now, these things are not just additive. It's not that you can say we have climate change here, 200 deaths, and you have air pollution there, another 200,000 deaths. We add them up, we have 400,000 deaths. It's not like that. There are synergies between air pollution and climate change, which will make that the number of deaths will be much more than 400,000, and the sum of the two. No? And this is what science can show us. So it's really climate change, heat waves, heat stress, and air pollution are really, I would say, a deadly combination, or a deadly cocktail, as you would probably write in papers. But it's really like this, and that's one of the putting two studies together, our study here, the Peseta study on heat stress, but also our air pollution studies, putting them together, we are dealing here with a really important issue if we don't deal it. There are solutions to that, but maybe we can talk about that later. I think I spent my 5 minutes. Coastal, we can talk about that, agriculture. What I would like to say, and also Juan Carlos will repeat that, so we sort of show that impacts are not just local, as member states maybe would like to say. European Commission don't deal with that, it's a local issue, we will deal with that. But there are spillover effects, Juan Carlos will talk about that. There is truly, we are dealing now with truly European infrastructure. The Commission is investing in, for instance, the Trans-European Network for Energy, the Trans-European Network for Transport. These are infrastructures that really make Europe more interconnected, and these things are being impacted or being potentially damaged by climate change, and so we are dealing with a European issue. So that's the subsidiarity effect Europe has to step in there. And also in terms of solidarity, we show that there are very big differences between Northern Europe or Southern Europe, or between one sector and another. And here again, Europe can step in based on its solidarity principle that one country has to help another country in terms of, in case of big disasters. So I think I stop here.
Thank you very much. And over to Juan Carlos.
Hi, good morning everybody in Copenhagen. Sorry we could not come because of the short notice there from Seville, we're far away. So I will go into the second part of this brief summary of what we did at JRC. This was like 40 people. So we did this biophysical impact analysis conducted by, let's say, natural science people. And then we did the economic integration. All in all, we had like 10 different impact categories, and from those, we integrated 8 of them, so most of them, into a consistent economic setup. The idea there is to be able to compare how each sector compares to the others in relative terms. And then we have like 2 main messages. So the first one is on the overall economic damage. If we put all these various impacts, for instance, the losses in agriculture production, in terms of yield falls overall for Europe, like this is for the reference scenario, which is a kind of business as usual. We have like a 10% fall in agricultural yields. If we add all the other impacts, river floods, additional river floods, impacts in human health, as Frank mentioned, all in all, we have that if this future climate, this is by the end of the century, will happen in today's economy, then we could have like an overall damage for the European economy of close to 200 billion euro. This is like 2% of GDP. This is an economic evaluation of the damage provoked to citizens or to households. And it is interesting also to look into the decomposition of this big number into 2 dimensions. First, on the source of damage, so what are the most important categories? And there we find, as Frank mentioned, that the most important one is human health. There, because we have an additional number of premature deaths of like 100,000 per year, then we have an extra damage of 130 billion. So out of the 200, like 2/3 of that is due to the health impact. On the rest of the categories, the second one in degree of importance is the impact because of damages in the coastal areas. There we have an estimate of the damage of around 40 billion. And thirdly, the third category in importance is agriculture, which is close to 20 billion. Interestingly, also the second dimension, so what is the geographical scope of this pattern of damages? It is interesting to see that there is a big asymmetry. If one looks at the impacts in the northern European countries and compare them to those in the south, in the central south of Europe, we found that the damage being negative in all areas, it is like 15 times bigger, 1.5, in the south of Europe compared to the north. So there is a big asymmetry when one looks into the disaggregated into the regional numbers of this study. The second result relates to the importance of having a coordination in the European adaptation policy. We did some simulations to test what would happen if only one region would suffer because of climate change and not the rest. So we can measure how the rest of Europe could be affected. And that we did for two cases. One was agriculture, another was sea level rise. And what we concluded was that there is a kind of additional effect in the rest of Europe because of trade effects. So imagine, for instance, that Southern Europe would suffer because of agriculture losses. We estimate a 20% fall in agricultural yields in the south of Europe. Imagine that the rest of Europe is not affected by climate change. If we run this simulation in our model, we get an additional damage in the rest of Europe because of the damage happening primarily in Southern Europe in agriculture. We have this 20-25% additional damage. Finally, also, I would like to remark a third family of results. We also run not only this case of business as usual or reference, but we also simulated what would happen if we would move into this 2-degree future in which we would stabilize the climate system to this level. And there we have the result that the overall damage would be reduced by approximately 60 billion. So we would move from 190 to 130 overall damage. And finally, I would like to mention some of the lines of further research we have in the agenda. As Frank mentioned, it is important to bear in mind that we are underestimating the overall impact of climate change because of three main reasons. Firstly, we are not covering all the damages related to extreme events, which are the most important ones. For instance, in agriculture, the effects of heat stress is not modeled in our modeling system. Secondly, also, for instance, droughts are not integrated into the economic analysis. So this kind of very important extreme events which are related to the variability of climate change are not modeled. Secondly, also we have other sectors which were not in the analysis, very important ones, for instance, effects of migration flows from other countries within Europe to Europe. This could be quite significant. Also impacts in ecosystems and biodiversity losses are not accounted for. And the third big category we didn't look into is the effect of possible catastrophic impacts of or abrupt climate change. If we would account for these effects, the numbers would be probably much bigger, but this is not in the modeling setup. This is in our agenda for further research later on. And finally, also, just to conclude, let me mention that we didn't account for the effects in the rest of the world or what could happen beyond 2100. We stop at the end of this sentence. Those are the main ideas we would like to
Thank you
stress.
very much.
Thank you very much.
And before we come to questions, can I first of all ask you to say who you are, and because it's being recorded, I keep saying this, but you'll get the message in the end. In particular, if you have a question for Juan Carlos, do say so clearly, because he can't see us, but he can certainly hear us. And you'll have access to both the speakers afterwards. Frank will be able to talk to you in the room behind us, and you can talk to Juan Carlos through a screen link with Elena over there. Right, Christina, you had a question.
Hi, Christina Reed. I'm writing with Climate Wire, and my question is for Frank Reyes on the number of deaths from heat-related stress impacts. And we have 200,000 here, and you said that there was an additional 200,000, and that doesn't add up to 400,000, but it actually adds up to more, and I'm not exactly clear how you do the math on that.
Well, as of today, we have about 100,000 people in Europe dying every year prematurely, as of today, because of ongoing heat waves and heat stress which are existing. By the end of the century, we would have an additional 100, right? So that comes to 200, which you read in the press release. What I was saying is these numbers are similar to what we calculate for air pollution, independent of climate change. If we have the air pollution as of today in Europe is responsible for 200, 300,000 premature deaths. Now you can say, okay, we add this up, climate change is 200 and air pollution is another 200, that makes 400, right? But it's not that easy. It will be more than 400,000 because there are some synergistic effects between climate change, heat waves and air pollution. And for a given air pollution, for a given amount of emissions that we put into the atmosphere, if you have a warmer climate, for instance, that will keep these emissions, these pollutants, longer over a certain area because you have blocking events and stagnant weather, so that people are more exposed to this air pollution, and so more people will die. And it's this linkage between heat waves and air pollution that is rather, well, leading to a lot of casualties in Europe, and which I call like a very deadly combination.
Right, another question. Olivier.
Hi, I'm Olivier Desibo from newspaper Le Temps in Geneva. Maybe a naive question, but can you put this study in context? It is the first one. Can you relate the numbers you produce with former numbers from other studies? Just
well,
comparison.
It's the second Peseta study. We had the first Peseta study, and when, maybe Juan Carlos can add then, when we did the first Peseta study, we were rather unique in doing this bottom-up analysis from climate scenarios all the way to impacts on the economy. Even the Stern report, which is so famous, didn't do that. They did some work on in individual sectors, but when they had to look at the overall impacts on the economy, they used a totally different modeling framework. So here, for the first time in the Peseta study, and the first one was published some time ago. We did this seamless calculation from bottom up to the end.
But
this is the second version, more comprehensive. In the meantime, other people have been doing the same. Yeah.
Yeah. Who is doing the same? I mean, I met not only the JRC, but maybe some other institutions.
Well, in the meantime, there have been some European projects funded by the European Commission. Climate cost. Maybe I leave over to Juan Carlos. We also use some data from these European projects to come up to the overall picture. So GRC is doing a lot of its work in the house, and about 30 people were doing that, but we also work in networks through European research projects, and major one was climate cost, and actually some of the data that we have in Peseta 2 come from this European project. Juan Carlos, you want to say something?
Yeah, maybe I can just, we did this first iteration of these studies in Europe, like 4 years ago, Peseta 1, and there our big number was like 60 billion overall damage of future climate today happening in today's economy. Now we get like 3 times bigger, this number, and this is mostly due because we have added one impact which has a non-market valuation, which is mortality or human health associated mortality. And therefore, a conclusion we get is that it's very important to add into the analysis these areas which usually are not integrated because of the methodological difficulties or the controversies in the academia. So in our agenda for the future is try to make an effort to better account for these very important non-market or say environmental effects which in the end seem very relevant for the overall assessment. And one could compare these numbers with other studies. I mean, with the Stern review, the numbers are much bigger, and that is mainly because the Stern is a global assessment, so it's looking into the whole globe, while we only focus in Europe. Also, they take into account what happens beyond the end of the century. This is a very long time approach. They also consider all these catastrophes, non-market impacts, ecosystem services losses, and so on. So that's the big difference. We are following, in methodological terms, a big, let's say, different pathway, because while the Stern review and other studies are taking a top-down approach, so they are using very aggregated estimates of damages, many times based on expert judgment. However, we run big models and we do a very detailed analysis bottom up, as Frank mentioned. So for instance, think of the rear flood assessment. One run, transient run for the whole century from today to the future takes 2 weeks in a computer with 100 processors. So this is big modeling, this is big simulation, and the resolution of the results we get is completely different. This is the resolution we need to understand the implications for adaptation, which is a regional or local problem. But the main message also we want to stress is that we have to go beyond the big numbers, because the big numbers hide a lot of heterogeneity, a lot of variability across space or because of different impacts. And this information is crucial for designing adaptation. And this is absent in this other top-down literature.
Thank you very much. Any more questions? Clive, and to say to whom your question is.
Clive Cookson from the Financial Times. Juan Carlos, I think you said that the 2-degree estimate of total damage in these sectors was 120 billion, and then 3.5 degrees, 190 billion. So I was surprised to hear that the additional 1.5 degrees would have such a small effect. Or did I misunderstand?
Yeah, that's the good numbers we got. So this is the relation between the 2-degree or this mitigation scenario and the future with 3.5. If we run the models, these are the results we get. And let me explain of this 60 billion reduction compared to the reference scenario of 3.5 global temperature increase compared to the pre-industrial. We get like more than half, like 34 is reduction in health damages, and then we have like 16 billion is a reduction in agriculture, and the sea level rise is 8. But I think it's very important to put these numbers into a broad context, because actually one it's not legitimate to say if we compare the reference to the 2 degrees, we can see the benefit of mitigation. This is not correct, because for 3 main reasons. First is all I mentioned, we are underestimating the effects of climate change. So there are many items which matter and are not in the analysis. So we don't know what would be the difference between these 2 scenarios in all this, abrupt climate change, extreme events, migration, ecosystem, and so on. Second reason is that there is a big category of co-benefits of mitigation policy which is not introduced here, which is air pollution. So all the benefits associated to a cleaner air in urban areas, this is not accounted for. And finally, also we have the very important effect in terms of energy security. A world in which we do nothing to reduce emissions would lead to bigger dependence of the European economy in terms of energy fuels, fossil fuels, and this has a big potential for disruptive macroeconomic implications in the economic system. However, if we compare this with a world where we change completely the energy system and we go through a low carbon economy, we will have a much smaller dependence on foreign fossil fuels, and then we wouldn't have this vulnerability we have today to energy shocks. So just to sum up, so I think one has to be careful when communicating the results, because it's not a proper reading to say that comparing these numbers is the benefit of mitigation. One should do a much more comprehensive analysis to do that.
But it anyway says that even at 2 degrees there will be a residual, there will be a lot of remaining climate change impacts.
But I'm making the opposite point. Yeah. I'm surprised that the effort to go down from 3.5 degrees to 2 degrees has such a small extra benefit. Because 60, I know he was, maybe I'm being stupid, but I think taking everything he said into account, I still think it's surprising that you're only getting 60 billion extra benefits from this.
What Juan Carlos tried to explain is that you cannot, the extra benefits of mitigation are not only the 60 billion. There are a lot of extra benefits.
I know. I'm not talking about those. I'm just talking about why is the 60 billion so small? And you have not answered that.
Because going to 2 degrees, look at all the havoc we see already around the world that we relate to
Yeah,
climate
but
change. And we
extremes.
are only at 0.8. We are only at 0.8. So going to 2 degrees is still 1.2 degrees to go. And that will lead to a lot of impacts that even at 2 degrees will be there and will be
Yeah, but,
huge.
but again, you're saying even at 2 degrees. I'm making the opposite point. I'm surprised that it is so great at 2 degrees and not that much greater at 3.5. Don't you understand my question? Do you understand, Tim, what I'm saying?
Yes, but
Do you agree that they're not
Yeah,
answering
but
it?
the whole community is looking at that. So
And I'm sympathetic. I want to communicate this, but I think you're not making it easy.
it is not easy. But if you look at impacts in terms of temperature increase, it's not a curve like that. It's a curve like that. Because once you have had the impacts at 2 degrees, 3 degrees, there's nothing left at 4 or 5 degrees probably. But this is
That's a very important point, because I would have thought if you're talking about extreme heat stress, the impacts would be much greater additively. But you're saying it's not. I mean, that's why it's an interesting result. And I think this can be reported in exactly the opposite way to the way you're saying it.
we can talk afterwards. But it's, these numbers are, we have to read them with careful because it says something of mitigation, but they don't tell the whole story. They tell something about what will remain at 2 degrees in terms of impacts. And then if you go further to 3 degrees, these impacts sort of have to level off. You cannot keep having impacts.
Well, okay, that is such a fundamental point. I don't want to take up any more time. But it's counterintuitive.
So the interpretation of the results should be done in the context of the methodological setup. And as we have not looked fully into the extreme events effects, which would be much bigger in the reference than in the 2 degrees, then that reading is misleading. So one has to be careful, on the way this is explained, because this is not an analysis where we are trying to have a conclusion of what are the benefits of mitigation. For that, we would have to do a different study. What we did was a study to understand from what is known now on the market impacts mainly, what are the implications of different climate futures, the reference and the 2 degrees, basically. But one cannot just like that take those numbers and make that interpretation. This would be not correct, even if one could, from a superficial reading, take that message. That's something up to you also to digest and communicate.
Would it help if either of the speakers could tell us the bounds of the estimates? When you, I take it that the figures of 60 billion and 190 billion are median figures. But what kind of range of figures were you looking at?
The range is huge. So we have the numbers are there are the ensemble average. So we use basically 12 climate models. And we run the models, the impact models with the 12 models, and then we look at the impacts and the cost and sort of take the average. Now the spread on the average is large, but being able to use these 12 models tells us there is still a lot of uncertainty, but we have a better grip on the robustness of the results. So if 10 of the 12 models say, okay, it goes a certain direction, and there's an increase in floods, for instance, then we know this is a robust result, right? Because 10 of the 12 models say that. Still 2, we have to look into that. That's a scientific activity. But the robustness is something that we have a better grip on using these 12 models. The uncertainty remains still large. The spread on the 190, do you have an idea? Juan Carlos, it can be anything between 100 and 300, I would say.
Yeah.
But,
I think that's also very important to this comment from our colleague in Financial Times. The uncertainties are enormous. For one of the sectors, we did 12 different runs for the same reference future, so the same 3.5 degrees temperature increase in the future. But if one makes use of the richness of the climate model community, there we have 12 different climate futures, depending on the climate models. There we have both a global circulation model and regional climate model. So different combinations of these global and regional climate models we have 12 different futures. And because of the uncertainty in projecting extreme precipitation, we get that the difference between the worst case overall for Europe and the best case for floods, just for floods, is 1 order of magnitude. So we have a big difference. If this goes to the level of regions, the differences are much bigger. It's not 1 order of magnitude, it's much bigger. So there is a lot of uncertainty in the different stages of the assessment. So there's uncertainty on the climate modeling, there's uncertainty on the modeling of the future evolution of the economic system, there's uncertainty on the biophysical models, there's uncertainty on the economic modeling. And one would have to make a consistent integration of these different sources of uncertainties to make the statements we would like to have or we would like to read from this report, but which we cannot. I insist on that.
Can I remind you again that both speakers will be available separately, one by screen, one, of course, in person, to chase these figures up a bit more carefully. Yes, a question here. Press answer. Yeah. I'm sorry, there's a...
India, there is this conflict between government-backed public institute and the UN study on the Himalayan ranges. While the IPCC report said that Himalayas will slowly begin to contract and that the glaciers will begin to give in, the government-backed institute has said nothing like that is happening to the Himalayas. There are two prominent views on this region, for instance. So how do you act, on which data would you take up as a reference point to act? That would be a difficult thing. So Europe also may be facing the same problem. The other thing is, you were saying Western Europe may not be affected too much, but during climate changes, I don't know if there's a choice of region where it affects and where it doesn't.
I'm afraid I didn't understand quite. We can maybe afterwards. You talked about the Himalayas, and yeah, well, this is a bit of a different issue than impacts in Europe, but we can talk maybe after the meeting, because I missed maybe half of your question, but it's about other areas in the world. The study didn't deal with that, but I can try to answer after the...
I think many of the questions are going to be local rather than global here. If there are no further questions, I'll bring the press conference to a close and remind you once again that our speakers will be available separately and by different media, one of them only in the flesh. Thank you very much, and thank you very much.
Thank you for coming.